Brighton Ruby. Thank you so much for having me today. That's a hard act to follow, but I'm going to try my best. My name is Emily Samp, and I am the engineering manager of the Ruby Developer Experience team at Shopify. So, as a team, our goal is to deliver an opinionated, state-of-the-art Ruby developer experience, both to Shopify developers and to the Ruby community. To do that, we build and maintain various developer tools, such as the Ruby LSP, IRB, Ruby Debug, RDoc, Tapioca, and Sorbet, which is what I'm going to be talking about today. Now, Sorbet is a Ruby type checker. At its simplest, a type checker is a piece of software that verifies that the values of the objects in your code match the values that you think they should contain, and then reports errors if they don't. So let's look at an example. So let's imagine we write a method that's meant to greet a user by name. So this method takes a string that contains the username and then concatenates that string into a greeting. Now, let's say down the line, you kind of forget what you meant to pass to this method. Maybe you think it actually takes a user ID, and so you give it a number. We've all done this before. And that causes an exception in your code. Well, Ruby is a dynamic language that, by default, doesn't have any type checking. That means that most of us are going to experience this kind of error when we run a test, or do manual testing, or in CI, or in production. I'm sure we have all had that experience. However, there are third-party type checkers for Ruby, such as Sorbet and Steep. So if we were using Sorbet, we could add a type signature to this method. Now, a type signature is a piece of code that tells the type checker what kind of arguments this method should take and what it will return. So it allows Sorbet to examine our code and tell us that there's going to be an error because we passed the wrong type of argument to this method. We do this before we run any tests, before we submit our code to CI, and before we hit production, which speeds up the development loop. If you've been in the Ruby community for a while, you will know that type checking is a spicy topic. Let me show you what I mean by that. So, on the one hand, type checking in Ruby can have huge benefits. We adopted Sorbet at Shopify about 6 years ago, and every year since, we've been surveying our developers to see, to learn about their experience using it. So, in 2024, more than 70% of our surveyed developers said that Sorbet helps them ship faster with fewer bugs. More than 80% said that Sorbet signatures give them the confidence they need to change code. And 85% said that Sorbet caught an error in their code. So it's kind of undeniable that Sorbet has had a large positive impact on how we write Ruby at Shopify. However, it's no secret that major voices in the Ruby community have been very outspoken against types in Ruby. This is a real keynote from Matz's Ruby Kaigi talk this year. I did not make this up. Or a real slide from his keynote. And he has been outspoken against types for literally as long as Ruby has existed. So if types are so helpful to Shopify, why do Matz and other people in the Ruby community oppose them so much? And they actually have valid reasons. So type checking in Ruby right now has some major drawbacks. Type signatures can make code look kind of clunky. Sometimes we end up writing code in a way just to appease the type checker rather than writing idiomatic Ruby. And Ruby's reliance on metaprogramming makes type checking actually quite difficult, which I'm going to explain more later in this talk. Basically, Ruby's flexibility creates a sense of joy. Its syntax is expressive and fun. Its capacity for metaprogramming makes frameworks like Rails possible. And type checking runs the risk of ruining all of that. So, where does that leave us? Is the Ruby community forever destined to be in two separate camps, one pro-typing, one anti-typing, never to agree on anything ever again? I don't think so. And I think that whether or not any of us individually want to put types in our application code, we actually can all be excited about advancements in Ruby type checking. And that's because of something called static analysis. So static analysis refers to a variety of techniques for examining code without actually running it. We've already encountered this in the talk so far. Type checking is a form of static analysis. Without running the code, the type checker examines it to see what types are contained in the objects and whether those types match what we expect. Every developer tool we use, from RDoc to our language servers to Rubocop, uses a certain amount of static analysis. The issue is that Ruby developer tooling needs better static analysis than it has. And I think that type checking is going to help us get there. Advancements in Ruby type checking are currently driving the development of type-aware static analysis tools that will enable Ruby developer tooling to match the intelligence, accuracy, and responsiveness that developers have come to expect in other modern languages. During this talk, I'm going to explain where Ruby tooling is today compared to other languages and why it could benefit from better static analysis. Then I'll talk about how we got here, the history of type checking in Ruby and other languages, and how that history relates to advancements in developer tools. Then finally, I'll show you where we're headed. Because even if you personally never add a single type annotation to your code, the future of Ruby tooling that's being built on these foundations is something that you should be excited about. So, to understand what improved static analysis could do for Ruby developer tooling, first we have to understand the current state of the ecosystem. The Ruby tooling ecosystem has a lot of tools that already use a certain amount of static analysis. We already talked about this. For example, most of us use Rubocop for linting. We use RDoc to generate documentation. We use the Ruby LSP to help us in our coding environment. And these tools are valuable, but they struggle with some fundamental limitations. Let's look at an example. So in this code, I create a hash that maps book titles to their ratings. Then I iterate through the keys of the hash in order to print all the titles of the books. If I were using Rubocop, it would give me a violation here. It would say instead of calling the keys and each methods, I should instead just use the each key method. This makes a lot of sense. It's better to call one method instead of two. It's more idiomatic Ruby. Okay, I'm on board with this suggestion. However, let's look at a different example. Let's say I create a class that represents a door, and I add an instance method that returns a list of the door's keys. Then I create a door object and iterate through all the keys belonging to that door. Rubocop is going to give me the same suggestion here, to use the each key method instead of calling .keys.each. Do we see a problem here? This is going to cause an exception in my code because the door class does not have an each key method. So why would Rubocop give me a suggestion that would break my code? That's so rude. Well, under the hood, Rubocop converts code into something called an abstract syntax tree. An abstract syntax tree is a way for computers to represent code so that they can examine the structure of the code and understand what is going on. So these are the syntax trees for our two examples. Rubocop is going to look at those trees and see the chained calls to the keys and each methods, and it's going to use those to determine that there is a violation of its rule. However, Rubocop's underlying static analysis is not powerful enough to know what the types are of the objects that have these methods called on them. So it literally cannot do any better than what it's currently doing. So we see similar issues in other tools as well. The Ruby language server is an LSP built and maintained by my team at Shopify. It is literally the state-of-the-art Ruby language server right now. The goal of the server is to provide helpful information to you in your development environment while you're coding. So for example, it might suggest methods that you could call on an object as you're typing. When we're not using Sorbet, the implementation of these features is done on a best guess basis. So as an example here, we're returning to our door class. If we create a variable called door, which is an instance of the door class, the Ruby LSP is going to see that the name of the variable is door, and that matches the door class, and it's going to assume that variable is an instance of the door class and suggest us methods accordingly. However, if instead I name the variable Baker Street 221B, then the Ruby LSP has no way of knowing what kind of object it is because of limits in its underlying static analysis. However, the Python language server doesn't have this problem. I could name that variable whatever I wanted, and because the Python language server has stronger static analysis, it is going to know exactly what kind of object that is. This is not to say that the Ruby LSP is bad software. Like I said, it is state-of-the-art for Ruby right now. It just cannot do any better than it is currently doing, because Ruby lacks high-quality static analysis tools. Because of these limits, Ruby tooling cannot be more helpful to us, cannot be as helpful to us as we would like it to be. So how did we get here? There are other programming languages like Python and JavaScript that are just as old as Ruby and almost as dynamic, and yet do not lack intelligent developer tooling. So how did they arrive at where they are today? We're going to examine the history of these programming languages compared to Ruby and see what the differences are. So Python, Ruby, and JavaScript were all released within 7 years of each other in the late 80s and early 90s. In the early 2010s, as Python and JavaScript were starting to be adopted at scale, it became clear that they had some pretty major limitations, which led to the creation of the first type checkers for these languages, both released in 2012. The later 2010s saw even more development for Python type checkers, and many of these type checkers are still in use today. Comparatively, the first comprehensive Ruby type checker was released in 2019. It was Sorbet, which was developed at Stripe. Ruby 3.0 was released in 2020, and that included RBS, which is another type checking syntax, and the corresponding type checker for that is called Steep. So we see from this timeline that investment in Ruby type checkers started almost a decade after Python and JavaScript. Furthermore, this led to disparities between the quality of static analysis tooling available in Ruby and in these other languages. Every Python and JavaScript type checker that was developed during this time provides the underlying static analysis foundation for some really important developer tooling. So for example, some of these type checkers power the Python and JavaScript language servers, which create a very excellent developer experience. Python has something called PySA, which is a type-aware security issue detector, which is built on top of PyType. And there are type-aware linting plugins for most popular Python linters, so we would avoid our Rubocop door debacle. By contrast, there are almost no Ruby developer tools that are built on top of type-aware static analysis. Why is that? There are a few possible explanations. The first is Python and JavaScript have a lot more widespread adoption. They are used heavily in data and the web. But that's not the whole explanation. There are companies like Shopify, Gusto, GitHub, and many others who are and have been using Ruby at scale for a while. Ruby is also the most dynamic of all of these languages, which makes it the hardest to statically type. So let's go back to our metaprogramming example that I showed earlier. When we use Rails, so for example, that belongs to author method call, it is creating methods at runtime. Those methods do not exist until you boot up your app. They do not exist statically. That means that static analysis tools literally cannot see that they exist. So to make type checking actually useful for Rails, we have to first solve this issue, which creates an extra barrier. Another issue is that Ruby has historically lacked shared tooling. So until a few years ago, there was no Ruby parser that you could just plug and play into any developer tool. The C-Ruby parser was never meant to be ported into any other project. Instead, there were at least 7 parsers that were each being used in their own projects, were all slightly different, and probably had their own interesting bugs and things. A few years ago at Shopify, we developed Prism, which is a portable Ruby parser that can now be used across these projects to kind of create a shared foundation for more of these tools. But it is extremely hard to create more advanced tools if you do not have that shared foundation first. Given the challenges that Ruby has faced developing comprehensive static analysis tools, will it ever be possible for us to achieve the kind of experience that other developers have come to expect? I think the answer is yes, and that's because we're currently seeing these developments happen at Shopify. So the Sorbet LSP is a language server also developed by Stripe that uses Sorbet static analysis to provide a better development experience while you're coding. So revisiting our previous example, we can name an instance of the door class whatever we want, like Baker Street 221B, and Sorbet will know exactly what kind of object that is because of its stronger static analysis. In addition to this, we can use features like go to definition, finding all implementations of an abstract class, finding all references to a class or variable, and renaming all instances of a symbol with complete accuracy because of the strength of the underlying static analysis. We've also developed something called CodeDB, which is a static analysis platform for Shopify repositories. So it uses Sorbet static analysis under the hood to learn things about the code base or perform operations to help us. For example, it can tell us how many files in a code base are typed and to what extent. And it can also identify pieces of unused code and then open PRs on GitHub to delete them. And so we've deleted thousands of lines of code with little human intervention, thanks to this tool. As a final example, we have IRB, which is the Ruby command line interface. So before Ruby 3.3, IRB relied on a combination of regexes and runtime reflection to give you suggestions for what methods to call when you're typing out an object. So for example here, I go back to my book ratings example, and if you type bookratings.keys, it'll give you a suggestion for keys, but it won't give you a suggestion for any method to call after that because of limits in its static analysis. However, in Ruby 3.3, Ruby core introduced a mode where you could use Prism and RBS to power this autocomplete feature, and it's a lot more powerful than it used to be. And in Ruby 3.4, it's actually the default, so if you're up to date on your Ruby version, you are probably having this experience every day. So these examples are just the best we can do for now. Imagine what we might be able to accomplish in the future. We could have more LSP features, like a feature that tells you the class or type hierarchy of any object in your code without you having to go digging to understand it. We could have better type inference in Sorbet with fewer method signatures. We could have type-aware Rubocop cops and not get suggestions that break our code. We could have LLMs that leverage all this information via model context protocol servers to understand and produce better Ruby code. And we can reach this future by investing more in type-checking Ruby now, and thus developing the static analysis tooling that will make all these dreams a reality. So I imagine that some people listening to this talk might still have concerns about type-checking, and I wanted to address them. Many people don't want to use type signatures in their projects, and that's fine. I don't think you should have to. Gradual typing, which is the approach that Sorbet takes, means that you choose how much typing to add to your code. So let's look at some examples. This is actually something we saw at Shopify recently. Imagine you have some sort of boilerplate method that retries a block of code when you encounter a network error. This is the kind of method that you might use all throughout your code base. You'll probably read it a bunch, you'll probably write it a bunch. And every time you might be wondering, what does this method return? And you have to double check that every single time. What if we just added a type signature to this method? Now this looks kind of scary, but essentially all that it means is when you pass a block to this method, whatever type that block returns, the method will return that same type. So as long as you understand the block of code you pass to that method, you know what type the method returns. This simplifies one of the core pieces of boilerplate code in your application. So we could also imagine a future where, for example, gems are typed. So even if the rest of your project is untyped, you could have some verification of the interface between your application and the gem API and make sure you're using it properly. This isn't 100% possible right now, even with Sorbet, but my team has developed some of the fundamental approaches in tools like Tapioca, which I'm happy to talk about later. So another concern about typing is that it goes against the fundamental philosophy of Ruby, which I think is true. Matt's developed Ruby to bring joy during programming, to be flexible, and typing constrains that to a certain extent. Matt has also expressed an interest in eventually having totally dynamic type inference in Ruby, meaning one day he wants it to be the case that the Ruby VM can just automatically know the type of any object in your code without us having to write out method signatures or type assertions. This is an awesome vision. However, building that kind of tool requires us to invest in earlier, less sophisticated versions of the same tool. If anyone's used TypeScript, 8 years ago, I'm sure you were finding yourself writing a lot of method signatures and a lot of type assertions. But now, the experience is much smoother. You have to do a lot less to take advantage of those features. Ruby can be the same. Our current clunky tools are just stepping stones to the more elegant solutions in the future. However, we cannot get to the invisible automatic types without first building explicit types. And speaking of clunky tools, many people don't like how clunky it is to type check Ruby right now, which I totally agree. However, there are paths forward here as well. So on my team at Shopify, we're currently working on building a new front-end syntax for Sorbet. So this is the type signature that I showed you on the previous slide. It is hard to read. It's really big. I had to explain what it meant. So instead of doing this, my team has implemented an RBS front end. All of the type signatures are in comments. The syntax is a lot more elegant. It's easier to read, it's easier to write, and it makes the experience of typing a lot more enjoyable. We're actually finishing work on that this week, and if you are interested in learning more, the QR code on the slide is a blog post written by my teammate Alex. So while there are many valid concerns to type checking in Ruby, they are rooted in the current state of type checking and static analysis. Instead of thinking in the now, I encourage you to think about the future of Ruby tooling and to see current tools as just stops along the way to a better destination. On the RubyDX team at Shopify, we are working on building that future into existence. So as I previously mentioned, we are finishing up the process of creating an RBS front-end syntax for Sorbet. We're also deprecating Sorbet's custom parser and replacing it with Prism, as I mentioned earlier. So this is going to set us up to make it a lot easier to support Sorbet in the future and create that more advanced tooling on top of shared foundations. Up next, we're going to work on a shared Ruby code indexer. So this is going to be a piece of software that can examine any Ruby code and give us information about it, and it can be used as the foundation for tools like Ruby LSP, CodeDB, and even Sorbet to make all of those tools more powerful and robust. And that's just the beginning. So through these projects, we're currently laying the foundation for the next generation of Ruby tooling. This is the generation that is going to eventually deliver on Matt's dream of fully dynamic type inference in Ruby. It's the generation that's going to give us tooling just as fast, accurate, and intelligent as that of other languages. And it is current advancements in Ruby type checking that are driving the development of the static analysis tools that are going to help us get there. Before I finish speaking with you today, I wanted to mention something that's near and dear to my heart, which is WNB.rb. WNB.rb is a virtual community for women and non-binary Ruby developers. We're going to be having a lunch today, so if you identify as a woman or non-binary person, please join us. I'll be waiting in the foyer to walk over. And also feel free to scan the QR code and join us online as well. If you're excited about the vision that I've expressed in this talk and you want to take the next step, you can check out some of these resources. I'll post these slides on my website before the end of the day. Even if you never want to go all in on typing, you can still explore adopting Sorbet or even the Ruby LSP in your projects to understand the current state of Ruby developer tooling, both the benefits and any potential drawbacks. Thank you for having me. I hope you enjoyed this mildly spicy talk. I'd love to chat with you both today during the conference and online. And most importantly, I hope you're feeling excited about the future of Ruby developer tooling. I know I am.